Hello everyone and welcome to my channel. In this video I would like to show you how to do a hello world and a small web server written in assembly for FreeBSD on an ARM platform, ARM64. Okay, let's do it. First let me create a directory to do the tests. And now let's edit the hello.assembly. We need to declare the entry point, and that is going to be a function that is going to be exported. So we declare global, and this function is called _start. We need to align for, and here important, we can have a look at the system calls under the following file, user include syscall.h. Let's start the definition of the function start. But actually before we do that, we need to have a look at that function with the system call. So let's open it. User includes sys and syscall.h. And we see here the syswrite has number 4. We can open a small terminal here and we can ask man write. And we see here the function takes a couple of parameters, a file descriptor, a buffer, and the number of bytes to write. The calling convention for the FreeBSD kernel is to pass the parameters from left to right under register x0, x1, x2, and so on. The register x8 contains the system call number. In this case, we're going to write number 4, and we're going to use number 1 also to do an exit. Then we need to call the system, and if there is any error, the carry flag is set. In this case, we're not going to look at the carry flag. We are just going to write a message to the output. So we need to put in the first parameter, the file descriptor. We set the standard output, and this we know that this is number 1, stdout. Next we load into x1 the address of the message hello, and x2 is going to be the length, and here we're going to define a hello length. We need to put in x8 the number for the write function, which is number 4. We call the kernel svc 0, and now we are ready to exit the program. Put into x0 the number 0, we put in x8 the number 1 for exit, and we call the kernel. We still need to define our function and the length. We do that the following way. Hello is a .rc, hello from FreeBSD, carriage return. We can also define the length as an equal. Hello length is the same as the current position minus hello. Now we are ready to compile the program. For that, I'm going to create a makefile where I'm going to compile the hello.asm. I'm going to link the hello.o to hello. In case we need, I'm going to remove all the objects hello, and if anything happens that the program crashes, I don't want to see any core. So here in our terminal, let's type in make, and we just compile the program. Let's try to run it. Hello. Yes, hello from FreeBSD. That's it. So let's have again another look at the program. We define the function exported as the start. We define that we want to print to standard output. We give the address of the string and its length as the parameters 0, 1, and 2. Call system write, call the kernel, and exit. Here I forgot to write this number 8. This is sys exit. If we want to inspect the function calls being done, we can also run it under truce hello, and we see that we call write with 1 as standard output. This is the string, and the 20 characters, which is the length. Alright, we are almost ready to write a minimal web server. How? I'm going to introduce a couple of things very shortly that are going to make our life easy afterwards. One of them is going to be a small macro to do system calls. So let's call it macro syscall for a certain number and macro. And here we know that to call the kernel, we need to put this number into x8 and then svc 0. So we just do it, move x8 with the number and svc 0. This means that we can just do here syscall number 4, which is going to be the system write. The same here, syscall number 1, which is going to be the sys exit. All right, let's compile it again. It compiles, and hello from FreeBSD. Nice. One last thing I would like to do, which is the following. We know that we have 20 characters, and I'm going to do something now that we don't really need to do, but it's going to serve as a good demonstration, and we're going to use this in our server. So I'm going to create a new section BSS. This is for non-initialized data, and I'm going to do a power 2 alignment on 3, so 2 to the 3, or let's do an alignment on 2 to the 4 on 16, and let's define here a variable where I reserve space for 16. Okay, so small typo, let's compile, and it compiles. This variable here currently is not doing anything, but let's define some macros. What I want to do is, instead of loading the length directly, I'm first going to save the value of the length into this variable. I'm going to load it afterwards. So in the beginning of the program, before I start moving anything in the registers, I'm going to write this into a local variable, into this section BSS, and then I'm going to load it again from there, which is and I'm going to load it into 2, and it's going to have the same effect. For that generic option, and this is why I want to do this, I'm going to define 2 macros, one which is going to write into the memory location, and another one which is going to load from that memory location. So let's start with the writing. The action that I'm going to do here is going to be equivalent as *mem equals to a variable, or let's call it a register. So this is going to be the things that we're going to want to do, the equivalent in C. Let's define a macro, mem store. Mem, it's a requirement, and the register is also a requirement. And macro, in order to implement this properly, we are going to need to use one of the registers that to load the memory address, or to load the contents, because the ARM CPU cannot use the addresses directly into the instructions. Therefore, we need a register for that, meaning that we are going to destroy potentially, when we call this macro, one register. To avoid that, I'm going just to do a push pop. So push in the beginning, push the value into the stack, and then pop the value of the register that I'm going to use. But as you see, I'm looking at implementing this function has a certain register. This means that I can potentially have a conflict on the register that I use to load the address, and the register that has the value to be stored. So I need to do a small condition here. If this register is not x0, else, and if. So let me just compile, and everything is still fine. Now here in this case, I know that the register is not x0. The other case is going to be really similar, so let me just write this. So what I've done here is, in the first instruction, I push the value of x0 into the stack. I load the memory address into x0. There is no problem doing this because the register has been saved before. I know that the register that has the original data is not x0. Therefore, the third instruction takes this register, which is not x0, and writes the value into that memory pointed by x0. The next thing is I recover x0 from the stack. So I do a push and a pop in the beginning. The only difference is, if the register is x0, I can just do, instead of using the x0, I use, for example, x9, and I'm fine. So there is no conflict anymore. Let's do a make. Yes, it compiles, so this is good. Now let's do the macro in the other way. So macro, let's load from memory. And now the instructions are going to be very similar, but instead of using a store instruction, I'm going to use a load instruction. And instead of the store, I do an LDR, and here again an LDR. Compile, everything is fine, we are good to go. Now let's change our program down here. So instead of doing a move x2, let's just, in the beginning, mem store on the variable. The value, here we can have the value hello len. Let's take this one here. Let's see if this compiles. It didn't like here, so let me actually put the hash It doesn't like. Okay, yes, because we have registers here, and I should load first this into another register. So let's say move now x9 to hello lang, and here x9. Okay, so this is now a separate. This is the setup. I'm using an x9 which is not used afterwards, and I'm just moving this value of the length into x9, and I'm storing this in the variable var. So it should compile, yes. And here, of course, instead of using this instruction, I use a memload from the var, and I load this into the variable x2. Okay, let's compile and let's run. Hello from FreeBSD. Hooray! So now this is working properly, and we understand that we have macros to load from memory, to store in the memory. Actually, let me just write here, this macro here is the same as register equals the contents of the memory. This is the memory load that we've just seen. This is the memory store, and we have a syscall for a certain value. All right. So we are now ready for our minimal web server. And instead of writing everything, I'm going to show you already what I've done before. And yeah, I'll be right back. So now here we are back, and I've just created a server directory, and I've copied the program, which I'm going to explain in short. The program starts by defining section text, where again we are exporting the function start. We have the system call for the number. We've seen this just now. So the memory load, the memory here it's memory save or store, and the program starts here. Let's open user include system syscall. Let's do it like this, and I look at the syssocket. So I just reorganized a little bit the windows. This the server starts by doing a socket, so it creates a socket. Let's see, man2 socket, and socket requires the parameters, which is the domain, the type, and the protocol. So I'm missing here actually in number 2, I'm missing the protocol. Let's put it like this. Before what I tried, it basically works because the registers, if I'm not mistaken, they start with 0 at the beginning. But let's see. So x0, this is domain, this is AF init. Domain, yeah, the syssocket currently understands a couple of things, and yeah, it should be the PF init. Then we have the sock stream. This is the second parameter. This is the type, is a stock stream, and then we have the protocol. The next thing is syscall for number 47. We have the parameter set up, so we do a syssocket, as we can see here, and a branch on carry. This program is really very simple. If there is any error at any point in time, it just goes and yeah, just dies, just doesn't work anymore. This returns file descriptor, so we do a mem save on the socket ft. We're going to see that this is also placed in the BSS section, and the result comes from x0. I forgot to say this before. When we do a syscall, if there is a return value, it comes over the register 0, and if there is an error, the carry set. Here we don't really need to do this, but just for completeness, I load now x0 with a socket ft, which it already has this value. And what am I doing? I'm looking at system bind. So let's, I want to do a bind. The bind is number 104. So let's start here, man2 bind. And the bind requires 1, 2, 3 parameters. So let's again see the 3 parameters. The first parameter is the socket we created before. So this is why I'm loading from the socket to the x0. The next one is the address of the sock address structure, which is in the host address, where I'm going to show that afterwards. Then we put number 16. This is the size of this structure, and we do the system call. And if there is an if there is an error, we exit the program. The next thing we are going, so we called socket, we bind, and now we're going to listen. Syslisten is the 106. The listen system call requires the socket in x0. Here, this is what we do. We load in x0 memory load, and the backlog is I select the parameter number 1 and call listen. All right, and once we're listening, we need to start accepting, and here we put a label again. So this is going to be a loop. Accept takes the following parameters: the socket, this address again, and the length. We put in the socket, we load again the socket ft x0. We load in the second parameter, we load the address of the client address, and here we see it's a length. It's we need a pointer, so we need another memory region here for the length. Another variable. We do the accept, call accept, and again branch on carry to the error. Otherwise, this creates again another file descriptor that we can read and write there, and we save this to the accept file descriptor with memory save, and then we do a branch to read in. So instead of following the program as it is here and as it's written, I'm going to go to the read in. So following the data flow, what are we going to do in the read in? In the read in, we are going to load first the file descriptor. We are going to load into x1 the address of the buffer. We're going to say that there is a buffer size of 4096, and we're going to do a sysread. So sysread from the beginning. Sysread is number 3, meaning we are going to read what is incoming in this in the request. This is going to be the request from the web browser, and we're going to load this into the with the read system call. Let's have a look at that system call. Read. The read system call, we need the file descriptor, we need a buffer, and we need a number of bytes. So this buffer has maximum 4096 bytes. So, and what we're going to get is an HTTP header with a GET request, and we'll be happy. What the browser sends in the HTTP protocol is GET and space some file name, and then HTTP another space and HTTP 1.1. So you can check that on the internet. So what I'm going to do here is I'm going to parse the file name from the browser's request. So let's go to the function parse file name. And so we load the buffer. The buffer was what just, so load into x0 the address of the buffer. This is what we just read from the socket. And I have a get string. Maybe I should go a little bit down here. So let me just show. So there is a section data. And if you remember the host address, so let me continue and explain from here. This is the data structure that we need in order to do the bind. I think it's the bind. So it gives a length, gives the type AF init, needs to bind to a certain port. Here I'm going to bind it to port 8080, which in hexadecimal it's written the other way around. So in hexadecimal it's 1F90X, which translates to decimal 8080. The IP address, I'm going to use only localhost or the loopback, which is reading from right to left, 7F127001. And the remaining part we don't need. The error message that we have is simply just saying error occurred. The header, this is something we're going to reply back. We need to send a reply saying HTTP 11 200 OK and carriage return, and then we give the content. And here is what I was just saying. There is the get string. So this is what I'm expecting from the browser. It's going to be something like get /index HTML and then HTTP 1.1 if I'm not mistaken. So it's something like this, but there is a space here at the end. This is going to play a role in soon. and this is a file name that we can just read and send it down through the socket. Since we are here, let's look at section BSS. So this is where I put my variables, which are not really initialized. So there is the client address, I have a client length, a variable for the socket file descriptor, for the accept file descriptor. For a read, I'm going to need to open a file for some bytes, the buffer, and the file name 1024. These are just some hard-coded values. Let's go back where we were. So this is the get string that we've just seen now. I load the memory address into the register x1, and into x2 I load the length. Here I start comparing because I want to know exactly that I have get space and a slash, and otherwise I just panic because this program has basically no error handling. And here it's what we're doing. So at least it's checking that we have a get request. So I'm going to load from x0, x1, so from the buffer I read from the socket, and I'm going to compare to what I'm expecting. This is what I expect, the get string, and this is the buffer, and this small loop here is comparing the thing. So I load a character into a byte into W3, W4. I compare them, and if they are not equal, I go to the error and I just exit the program. Otherwise, I increment both the pointers in the x0, x1, and I decrement my loop counter until my loop counter is 0 and I'm exactly at the point that I want. Now I load again into the x0 the input from the socket. Again, it has get slash etc. And I move into x1, the length of the get, so I can just skip it. So x0, x0, x1. So I just skip the part with the get. So skip this, and after that I have a file, and it's not going to be from the root directory, it's going to load from the local directory. So what I'm going to do next is to take the file name until I find a space, and load this into this variable file name, and this I do here. So here I just load into the memory. I skip the part of the get slash. I load into x1 the destination for my file name, and here x2 is going to be the counter of the number of characters that I copied. And there is again another loop here, and in this case is to load the file name. So I load from the buffer. I compare to a space, and if it is equal, I'm going to do a null termination on the file name because I need this to open the file. Otherwise, I store into x1, which is my destination. I add the both pointers, I increment them, and I do a loop again. Again, very less error handling. The null termination is just putting the value 0 into the x1. The next step is sending the header, basically saying, okay, everything is fine. So I'm already saying everything is fine before even opening the file. But here I take the accept ft, load it into x0. I put the address of the header, as we've seen before, its length, and I call write. I say the first thing I send is, hey, everything is fine, apparently. If there is an error writing, then I go to error. Otherwise, I go to send the file. What do I need to send the file? Well, the file name already has the name of the file that the browser is requesting. So I just need to open and read, and send on the sockets. Send, and that's it. That's my server. So let's go up to the send file. So we saw before we branch to the read in, and when we arrive to this point, we are ready to send a file, and we know that the file name has the name of the file to be loaded. So that's the first thing that we do. We load the address of file name into x0. We want to do a sysopen, so it's number 5. So let's go to the man open. The first parameter we need is a path, which is again why we need the null terminated string, and this is loaded into x0. x1 is going to have the flags. In this case it's 0, read only, and we don't need anything else. So just call sysopen, and if there is an error, just error out. We get a file descriptor back in x0, so we save it in the readFD variable. And now we are in the read loop. So let's see here. So the read loop, what again, I really don't need to do this. Oops, this is moving too much. So I don't really need to read again from FD into x0, because I know that when I come from this direction, it's done like this, but that the value is already in x0. But imagine that you are jumping from another part of the program that you don't know. Maybe x0 has been modified if you're branching from somewhere else. So it's a good thing that I store this here, and then I just say, hey, maybe you arrived to this label here, you don't know exactly if x0 is current or not, so let's load x0, make sure that it has the file descriptor. And what we want to do is the read. Again, the first parameter, file descriptor. Second parameter is the buffer. Here I go and I use a little bit less than the 4096 just for fun. I put in x2, I say you can read up to 4000 characters. Syscall read. If there is an error, branch on carry to error. If I didn't read anything, this is the end of the file, and I go to the close file, branch on equal to 0. If not, I was able to read something, and I'm going to push this stuff down the socket. So move, so x0 is contains the number of characters that were read. This was the output of the sysread. And I'm going to need to load x0 with again with the except fd, so the socket. But since x0 contains the number of bytes, I need first to move this to x2 and then load the file descriptor into x0. Otherwise, I would destroy it. So it needs to be done the other way around. The x1 is going to be the address of the buffer. I do a syscall for number 4, which is the write, as we've seen before. Here it is, the syswrite. And again, I branch on carry, and I go for the read loop. How do I exit this loop? Well, when there is nothing more to be read, I go to the close the file. And closing the file means I look at the readFD. Again, it's I don't know exactly what is in x0, so I go and fetch the readFD from the variable, and I call the close if there is an error again. Here the same thing, except, and load into x0, call the system close, which is number 6. Here it is, system close, and if you look at system close, it just requires a file descriptor. And then I branch to again. Here it is again, and everything just continues. It goes to an accept, because the socket basically is closed. We close the socket on our side. In case there is an error, we have the small routine here. We load the standard out. We load the error message. Here in this case, I hard-coded that the error message is 20 characters long, and I call syswrite, and then I do return code 1. There was an error, and syscall number 1, which is system exit, and we are done. Did I forget to explain anything? I don't think so. We have the read in, the write message. So we the write message we are actually not using anywhere. So this could be taken out. Branch, so write message. And from here we actually don't need to do anything. So just let's compile, make. here you see that in the make file, so let me open, is a slightly different thing. So I compile with CC, I do a link, and then I remove the section .comment, make the file a little bit smaller. If you want to have the -G, you can add debugging symbols to the compiled file. This makes it easier to debug with LLDB, for example. So I don't want debugging symbols, so let's just have it like this. And what I'm going to do now is, if you look at the files that are here, I just have makefile, the server, which has been compiled, the server.o, the object, the ASM. Let's see how big the file is. This server is 2416 bytes long. Wow, that is really small. In the meantime, create a new file. Yeah, it's things are a little bit tiny, so I'm going to eliminate this one. I'm going to eliminate here, and hello from ARM64 web server. Okay, and let's write this as index.html. So we have a new file here, which is index.html. Let's launch a browser, so Falcon, and let's go 127.0.0.0.0.1 port 8080. Cannot be reached because I have not started. And that was good to demonstrate that there is actually nothing running. So if we reload, there's nothing. Now we start the server. Well, it's running, something is happening. Let's see, and let's reload. And here index.html. And hello from ARM64 web server. How nice. And I think the program, yes, an error has occurred. And this error has occurred because if you debug the program a little bit, you're going to see that it's going to try to download something. So let's try to debug the program. And here we say LLDB on the server. We say break on the start. And let's add another breakpoint on the error. So let's run. As we can see, this is the start of the program. So at this breakpoint, we really didn't need it. Let's continue. And now we reload the page, and we see that it stops here in the error function. And now we try to look at the contents of the file name. So if we print file name, this doesn't give us what we want. But we can trick the system a little bit, saying, okay, this is actually a char star, which is the same as a string. And because this is already the contents, we put the address of the file name, and we should be able to look at the contents. And it, as you can see, it's trying to load the favicon.ico. Okay, so let's quit the program and let's just touch this favicon ICO. Okay, so now we have a favorite icon and we have an index, and let's run the server again. Server, let's run it again. Okay, reload, nothing changed, but the server is still running. Okay, so this is the loop. Let's try to change index.html, saying put an anchor, href, test HTML, and here click me and stop the anchor. And let's add test HTML. Let's add well done. Okay, so let's see now the files again. We have the index.html, we have a test, and we have the favorite icon. So let's start the server. Let's go again to here. Let's reload. Okay, yes. So in this case, it doesn't identify the things correctly, and this has to do with how the communication is done, that it's not really saying what is the content type. It should say that the content type is HTML. So I'm going to try to solve this in two different ways. Let's see. The first one is I'm going to remove the hello. Okay, and the server is still running. So let's reload the page. And yes, I tricked the browser into seeing, okay, this is HTML code. So let's click here. Yeah, well done, well done. So that is pretty good. The other way, actually I'm not going to do this now. This video is becoming a little bit long. If we look at the server.as, we could add in our reply, let's see, where is our reply? The HTTP 1.1 200 OK. We could actually add in the header that the content type is an HTML document. We are basically giving no information to the browser that what follows is an HTML document. What we could have here is saying, okay, this is the body, because it's typically how an HTML document starts, and here /body. Let me see if this is going to work correctly. Let's go to the browser and again go back and reload the page. Yes, hello from ARM web server, click me. Just I'm a little bit of a perfectionist, so let me just add a break here. Okay, and let's reload the things again. Yes, and now the click me is down, and if we click on the click me, we are well done. This on the page well done. And as you can see, it's a really small web server, so you with a binary of 2416 bytes.